Okay, hi everyone. Okay, so we will get into the complete map of the course EASY 8551 communication networks. Okay, so this is as per Anna University 2017 regulation syllabus. Okay, so here I have already took one video, okay, which is going to cover the topic OSI model, TCP/IP model. Then I have given some intro about IEEE 802.11. Okay, so if you want to go through that topic, okay, so I have given the link in my the district in the description box. Okay, so now let me just proceed with the presentation. Okay, so in your unit one, okay, so what is the what are all the topics? You just see the topics you have. So overview of data communication, networks, building networks, and its types. Okay, so then after that overview of internet, then protocol layering. So, so this flow, whether can you able to understand? So overview of data communication. What is actually overview of data communication? Okay, let me just go back and okay, so we all know what is a network. So it is an interconnection of two or more devices for sharing of information and resources. And we know we have many applications for this computer networking. So then we have some parameters which are all related to the networks. Okay, so here we can divide the communication into three types: simplex, half duplex, and full duplex mode of communication. And so here the network performance, we have some parameters, okay, to measure the network performance with respect to delay, reliability, and security. Okay, then also the network topology. Okay, so the network topology, in what shape the network is established. Okay, so in case of mesh topology, we can see that every node is connected to every other node. So it is quite difficult to configure mesh topology. So network topology, it is all about in what shape the network is established, and the media. Okay, so the transmission medium, that is the cable, it plays a major role in case of wire networking. Okay, so we go with twisted pair cable, then copper cable and optical fiber cable. Okay, optical fiber cable is mostly preferred because it provides wider bandwidth. Okay, so like that we can study so many concepts related to network. Okay, but anyhow, with respect to the syllabus, okay, the first thing you should know what is the OSI model and what is the difference between TCP/IP model and OSI model. Okay, if you have to get an idea about OSI and TCP/IP model, please go through the video which I have already posted. So the details are given in the description. Okay, now let me just proceed with the remaining topics which I need to cover. Okay, so then you can see. So we have an important concept, error detection and error correction in networking. Okay, so under that we have many techniques for error detection and error correction. Okay, we know error detection means it will detect only the error. Error correction, it will detect also, it will correct it. Okay, so as a digital data we are transmitting ones and zeros. It is a sequence of bit streams, ones and zeros. Okay, so we should know in which position my data got corrupted. Okay, so error correction means it has to find out at which position the data got corrupted, because it is all zeros and ones. Okay, once if I say in eighth position, the eighth bit, okay, in my sequence of bit stream, the eighth bit is corrupted. Suppose if the eighth bit is zero, then it is understood that it is actually, it is 1. Okay, the 0 while transmitting, it has been modified as 1. So so I'll be changing it. Okay, so now we have some techniques. Okay, we have in error detection and error correction. Okay, so in the beginning of this concept, okay, in the beginning of this error detection and error correction, uh, they have used simple parity scheme. So in case of simple parity scheme, you just see the illustration. Okay, so what we will do is that the sender, when transmitting the bit stream, okay, so it will add one more bit called parity bit. Okay, the sender it goes for either odd parity or even parity. Okay, suppose if I go for even parity, then what it will do, it will see the number of ones in my information. So here number of ones is 1, it is odd in number, so I will make this parity bit as 1. So now 4 number of ones. So now so it is even number of ones. So this is in even parity. Okay, so what it will do, the receiver, if it is in even parity, it will accept it. Suppose if it is in odd parity, then it will reject it. It will ask the sender to retransmit the information once again. Is it clear? Okay, between the sender and receiver, we are deciding in what parity they are going to transmit. Now sender is assuming an even parity. Okay, so accordingly it will make the change in the parity bit. Okay, it will see the information how many number of ones. Okay, so here number of 1 is odd, but it is assuming for even parity. So it makes the parity bit as 1 so that it becomes 4 number of ones. Okay, so so number of ones are even. So this is even parity. Now what a receiver it will do. So after receiving this bits, now the receiver is seeing whether it is an even parity or odd parity. So if it is in even parity, yes, then it will accept it. Suppose if it is in odd parity, then it means that, okay, so this is the bit stream we are going to transmit 1 0 0 0 1 1. Okay. So during the transmission over the medium, so the data might get corrected. If it is receiving in odd parity, it is the meaning that so so we have to understood that, okay, during the transmission over the medium, the data got corrupted. So that is why from even parity it is changed to odd parity. Okay. So but by using this simple parity scheme, I can able to detect only single bit error. Okay, for the burst error. Okay, that is more than one bit got corrupted. That is called burst error. Okay, so then this parity scheme won't work. Okay, it became failure. Okay, so they went for some other alternate technique. Okay, so we have two-dimensional parity check, then checksum and cyclic redundancy check. Okay, now we will go the two-dimensional parity check. Okay, here now we are going to find out the parity in row wise and column wise. Okay, so for example, if I'm assuming for an even parity, okay, so assume this is my information. Okay, so this information you can see it consists of 40 bits. Okay, what I will do is that this 40 bits I will divide it into 4 blocks. Okay, so each block of fixed number of bits. So in this case, each block it is of 8 bits in length. Okay, so now I'll be writing this blocks in one after another. This is first row. So the first row is 1 double 0 double 1 double 0 1. Then the second row is triple 1 triple 0 1 0. Then third row I will be writing. Then fourth row. Now I am going to add one more row and one more column. Okay, also I'm going for an assumption that I'm going to send in even parity. Okay, so what I will do, so I will take the first row. You see the first row, it contains 4 number of ones. So it is in even parity already. So to make it even parity further, I will make this parity bit 0. Again, I will take the second row, triple 1, triple 0, 1, double 0. Okay, so now it is in even parity, so I will not make any changes in the parity bit. I will make it as 0. Similarly, in other third row and fourth row, okay, so already it is in even number of ones. Again here it is even number of ones, so I will make the parity bit as 0. Okay, now this fifth row, how do I calculate? So I will take the first column. Okay, so first column it is odd number of ones. To make it as even parity, I will make this parity bit as 1. The second column, you see it is in odd number of ones, so I have to make this parity bit as 1 so that it will become even parity. Then the third column, you can see in the third portion we have 0 1 1 0. It is already in even parity, so I am making the parity bit as 0. Okay, so likewise I'm doing the calculation, okay, for the remaining bits. Okay, if I have check this fifth row, again we can see how many number of ones, 1 2 3 4 5 6. So it is already in even parity, so I'm making this parity bit as 0. Okay, so now what I will do is that I will add this fifth row. Okay, actually it contains 4 blocks of data, but when I'm transmitting, I will be adding the fifth block of data. Also, additionally, we can see that each block it is of 8 bits in length, but here instead of 8 bits, I have to transmit 9 bits. Okay, so the thing is that because we are adding a row in, we are adding a parity bit in row wise, also column wise. So instead of 8 bits, I'll be transmitting 9 bits. What is my information? Actually, what is my information present in the first block? 10011 001. Okay, along with that, I will include one more zero here. Okay, so now we just calculate what is the overhead we have introduced. Overhead means actually the information only we are trying to communicate. But in case of error detection and error correction, in addition to my original information, okay, I'm adding some extra bits for the purpose of detecting error and for error correction, for the error correction to be facilitated at the receiver side, receiver end. Okay, so in each row now actually how many bits actually I have to transmit. So each block it is of 8 bits in length. There are 4 blocks. So 4 into 8 it is of 32 bit. Okay. So then we are introducing a parity bit column wise. So here how many how many extra bits? So we have to include here is 5 bits. Okay. So 32 bits plus 5 it is 37. Again, I'm adding one more row that is of 8. Okay, it is of 8 bits in length. So 32 plus 5, 37 plus 8, it is of 45. So instead of transmitting 32 bits, okay, so we can see that so 32 plus 5 plus 8, that is 37 plus 8, it is 45. Instead of transmitting 32 bits, okay, now I'm transmitting 45 bits. Okay, so 45 minus 32 is the overhead we are introducing here. Okay, for each and every technique we have an advantages also disadvantages. Here advantages that it facilitates error detection and error correction capability, but the disadvantage is that, okay, instead of transmitting 32 bits we are transmitting 45 bits. Okay, so it consume extra bandwidth, extra time, okay, extra memory. So that is the penalty we have to pay for it. The third interesting technique is checksum. So what in case of checksum calculation, what we will do again, we will divide the sequence of bit streams into equal number of number of blocks. Each block it is of fixed size. Okay, so now it is of we can see it is of 8 bits. Each block it is of 8 bits in length as usual. So I'm going to consider the same data. Okay, so what I will do is that, so here I will be performing the summation, okay, binary addition. So if I add these two blocks, okay, first I will be writing 1 00 11 001. Okay, then I will be writing 111 So now I will perform binary addition. So 011 011 000 011 011 011 011 then 11, we know that sum is 0, carry is 1. Okay, so this end around carry I will be adding it to the LSP bit. So again, what we will get 1 it is 0. So sum is 0, carry is 1. So 1 sum is 0, carry is 1. So 1. So here actually 1 sum 0, carry 1. So 1 again sum 0, carry 1 1. So this one will come, this one will come, this one will come here, this one will come here. So here I'll be having 0. Okay, now I'll be adding this result with the third block. So what is third block? We have 001 00 So 001 So if I perform binary addition, 0 0 0 0 0 0 0 sum 0, carry 1. So 1 sum 0, carry 1. So again 1 sum 0, carry 1. Okay, so there is a carry 1 here. We have an 1 So for 1 sum is 0, carry is 1. So 1, so already I haven't carry 1. So 0 plus 1 1. Again 1 sum is 0, carry is 1. So in this way, I'll be adding next the fourth block of data. What is my fourth block of data? 4 zeros 100. Okay, so one four zeros, 100. So if I add 0000000, we all know, right? I hope you know the binary addition. So if it is 00, the sum is 0, 01, sum is 1, 10, sum is 1, 11, sum is 0, carry is 1. Okay, I forgot to say that. Okay, so using that only we are performing like this. So again, I'm adding the fourth row. So the fourth row I have added. Okay, so I'm getting this summation because there is an end around carry. Again, I'm adding this end around carry. So what I get is 0, 0, 1, 0, 0, 1, 0, 1. Okay, so now checksum actually is it is one's complement. For the sum, you take one's complement. So what is my sum? 0, 0, 1, 0, 0, 1, 0, 1. So checksum, you just take one's complement. So 0 will be converted to 1. So 1, 1, 0, 1, 1, 0, 1, 0. Okay, so what I will do is that when I transmit, okay, actually how many bits I have to transmit? So here it is of 32 bit. So along with the 32 bit, I will be adding one more 8 bit, that is the checksum. Okay, so now receiver, what it will do? Again, it will calculate the checksum. Okay, wow. So we all know that by adding these 4 blocks of data, what is the answer I will get? 0, 0, 1, 0, 0, 1, 0, 1. Okay, so this should be my answer. Without performing itself, we can directly write from this calculation. So 0, 0, 1, 0, 0, 1, 0, 1. So to this, I have to add the fifth block, that is my checksum column. What is my checksum? So 1, 1, 0, 1, 1, 0, 1, 0. So I'm going to add this. Okay, when I add this, we can see that 1, 1, 1, 0, it is 1, 0, 1, 1, 1, 0, 1, 0, 1, 1, 0, 1, 1, 1, 0, 1. 0, 1, 1, 0, 1, 1. Okay, so this is sum. So in order to calculate the checksum, I have to apply one's complement. If I take one's complement, all the ones will be converted into 0. Okay, so what is the inference? That is, what is the concept actually here we are taking is that, okay, so on the receiver side, it will calculate the checksum. So in case of checksum, if all the bits are 0, then it assumes there is no corruption in my received bit. Okay, suppose even if any one of the bit is non-zero, then it rejects the received bit and it will be asking for retransmission. Okay, but now here we can see all the bits after my checksum calculation at the receiver side, it is 0. So it can accept it and it says that no error has occurred during the transmission over the channel. So this is a very easy checksum technique. So next very interesting technique we are going to see is cyclic redundancy check. Okay. So the fourth technique, see the what is the next technique we are going to see is a cyclic redundancy check. Okay, so in cyclic redundancy check, okay, we will be given with the original message, okay, then generator polynomial, then CRC generator, okay. So my original message will be in dividend. What is my original message? 101 zeros. Okay, then to this I'm appending some zeros. These number of zeros to be added is equal to n minus 1, n minus 1. Okay, that is in my CRC generator, how many bits? So they are saying this is the CRC generator you have to use. The CRC generator is 1001. So how many bits it is? 4 bit. Okay, if in suppose if my CRC generator is having n bits, then I have to append n minus 1 zeros with my dividend. Okay, so this is my dividend and this is my divider, this is my quotient and this is the remainder. Okay, so I'm adding 3 zeros. Okay, so now I have to perform XOR addition. In case of XOR addition, I know that 0 0 it is 0 0 1 it is 1 1 0 it is 1. For 1 1 it is 0. Okay, so for 0 1 1 1 0 1, okay, 0 0 0 1 1, even if both the bits are same, then output will be 0. Okay, 0. So then you please write these position as such. So I have 000 again 000. Okay. So now always we have to start with the we have to start with the what to say, so with 1, okay, because 0 doesn't have any value, so I have to start from here. So what is my divider? Okay, what is my divider? So the divider, so they have given the generator polynomial. So what is my generator polynomial? The generator polynomial is x cube plus 1. So it means that it consists of degree 3, then degree 2 is 0, degree 1 is 0, then it has only constant term. So that is why we are writing the CRC generator is 1001 and it is having 4-bit. Since the CRC generator is having 4-bit, then I have to append. If CRC generator is of n bit, then append n minus 1 zeros in the end of the original message. Okay, so I have to continue this problem. Okay, so finally I have to see what is the remainder I'm getting. Okay, so the remainder what I'm getting is 0 1 1. Okay, what I'm getting is 0 1 1. Okay, so what it will do is that whatever remainder you are getting, okay, so it will add in this place. Okay, initially we have added n minus 1 zeros, so in this place I have to add the remainder. So if I add the remainder, so I'll be getting 1010 000, then this remainder 011. Again I perform the calculation. So after my calculation, if all my bits in my remainder is 0, okay, then it is accepted. Suppose even if any one of the bit is non-zero, then it will reject it. It will ask, the receiver will ask the sender to retransmit those bits once again. Okay, so this is going to be very, very interesting. Okay, so again I'm repeating. So students, in unit 1, error detection and error correction, then for the TCP IP and OSM model, so I have completed this video. Then another topic here, it is given link layer addressing. This link layer addressing again, so in my first video itself I have explained what is called physical address or MAC address. Okay, now we shall move on to the next unit.